Welcome to Kitchen Chemistry. I'm Aaron, and today we're going to play with some common household kitchen items in some uncommon household kitchen ways and see what happens. But we're not just going to see what happens. There's a reason why things happen, why things might change color or bubble or do something else. And observing those reasons and figuring it out is called science. Before we begin, I want to remind everybody, if you try this at home, which you should do, please be safe, which means you protect your eyes in case there's a splash. It means you don't drink or sniff anything that you shouldn't drink or sniff. And it means you ask your parents first before you begin. Also, and this is for the parents, please remember whatever mess you might make, and you might make a mess, please clean it up when you're done. The first experiment we're going to try today is discovering what is an acid and what is a base. Different kitchen chemicals, some have a different pH, and that means some are more on the acid side of chemicals, and some are more on the base side of chemicals. And we have a litmus test made out of red cabbage juice. Don't you guys like to drink red cabbage juice? I understand that it looks like it's blue. It was made from red cabbage, and if you just boil some red cabbage on the stove, you can eat it when you're done, but drain the juice and you can try this experiment. So with red cabbage juice, if something is a base, it will stay blue or even turn more blue. If something is an acid, it will change to a different color. So, I have some vinegar. What do you think vinegar will do? Is vinegar an acid, which will be a different color, or blue, which is a base? Let's find out. Adding vinegar to red cabbage juice. What happened? This vinegar turned pink. So pink is the color, and if red cabbage juice turns to pink, it is an acid. Vinegar is an acid. Okay, what's next? I have here some ammonia. Ammonia is used for cleaning. It's not used for eating or sniffing. It has quite a strong smell. Is ammonia an acid or a base? Nothing. Ammonia is definitely a base. So one acid, one base. CLR, calcium, lime, and rust cleaner. And if I read the back of this, it has the ingredients on it. And in the ingredients it says it has gluconic acid. What do you think it's going to change to? CLR. Ooh. All right. It's kind of like Christmas right there. We have an acid, a base, and an acid. What about a mint? Here's a Lifesavers mint. Well, I thought I could break this Lifesavers mint. Broke it now. A mint. Oops. I don't see any change. It's not an acid. We might let it dissolve and see if things change. What about ibuprofen? Same thing. It might have to dissolve. So we'll let that work and we'll come back to the mint and the ibuprofen. What about hand sanitizer? Acid or base? Let's see. Looks like it's not an acid again. What about, this is a tricky one, my breath? Acid or base? Let's see where we are here. We just did the hand sanitizer. Get anywhere? That's kind of messy. Well, I've read the carbon dioxide in your breath can help make that more acidic. I don't see it happening in our experiment, but that is still blue. Okay, well, moving on. This is called antacid. What do you think? Antacid, acid or base? Ant is like anti, which means not. So I'm going to bet that this is not an acid. Nothing. What about if I put this in an acid? We know these are acid. Antacid, acid. Maybe we'll come back and see if that did anything. It's bubbling a little bit. It's bubbling more. Okay, we have some all-purpose cleaner, acid or base. Turned a little bit greenish, I think, because this is a little bit yellow. But base. Window cleaner. Kind of foamy, but a little bit of a base. What about over here? Let me get my clock out. Yes, that's my clock, or my light. This is my light. We'll talk about that later. I wonder if the juice from this lemon would be an acid or a base. Lemon juice. Ooh, we got one finally. Juice from a citrus like an orange or a lime or a lemon, along with being a light, is an acid. If we go back to this antacid, I don't know. Maybe it made it a little bit blue, maybe not. Okay, so that's our science experiment about acids and bases. Welcome back. It's Aaron again with Kitchen Chemistry. We were talking about acids and bases and how red cabbage juice, which is blue, changes color whenever acids are added, and we have some changes to our experiment from before. Remember, our vinegar was an acid and it changed very, very pink. Well, we had a couple that we had to wait and see what happened. This is the ibuprofen. And now that the pill is broken up a little bit, it's kind of a cloudy pink. I think that has some acid to it. And then definitely what's cool, this was hand sanitizer. And what we forgot to do with the hand sanitizer, or didn't do a good job, was stir it. It just all globbed at the top. But as soon as I stirred that up a little bit, well, I'd say we definitely have an acid in the hand sanitizer. So another experiment that's similar to that one, it's not as red and blue and colorful, but it's still fun, is with this. This is just a nice glass of black tea. I know black tea is brown, just like red cabbage juice is blue, but black tea, which brews to be brown, also works as an indicator of pH, of acid or base. So I will dump my tea into the cup. I don't know if this cup is safe, but as of right now, you could have drank the tea. It's just plain old tea. When you add an acid to tea in a good amount, the tea loses its color. It turns clear, or at least it turns to a lighter brown. So if I add an acid to my tea, and this is vinegar, vinegar is an acid, we'll see if it turns a lighter brown. What do you think? A little bit lighter just because it got full of a clear liquid, but the acid took some of the color out. What else we can do with the tea? If we add a base to the tea, it will bring the color back to dark brown. But something we haven't played with yet, if you mix an acid and a base together, they might not get along with each other. So I think two things are going to happen here. Hopefully we see this turn more brown than it was. Also, we may see the baking soda base react with the tea, and we'll see what happens with that too. If you've mixed baking soda and vinegar before, you know what's going to happen. All right, see if the color changes and see if anything else happens. Are we ready? Here we go. Woo! Well, we have a little volcano going on, don't we? And who even knows what color the tea is from all the bubbles? We'll have to wait until it settles and see if we get it back to its dark color or not. It's kind of drippy. Maybe a little bit darker. Not a big change. We definitely did see a reaction though when an acid meets a base. It makes a little volcano. I'm going to tell you about an experiment I performed last night at my house. I was sitting around the house thinking about science and the power went out. The lights went out. What do we do? Well, I say when life gives you lemons, make a light. And I took my lemons and I plugged some wires in and lit up my light. Simple, right? Do you think that would work? Well, watch this video and you'll find out. So what I have here is a series of lemons and wire and paper clips. And you can see it's a copper wire to a lemon to a paper clip to a copper wire to a lemon to a paper clip to a copper wire to a lemon to a paper clip to a copper wire to a lemon to a paper clip. And here is my little LED light. So can copper wires, lemons, and paper clips make this LED light? Well, we can touch them together here and see if this really does happen. Ta-da! Ta-da, 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 ta-da. The power of lemons. Hi kids, our final experiment of the day has to do with this bottle of Diet Cola. And what we're going to do is we're going to remove the carbon dioxide that is dissolved in the cola. Right now, there's no bubbles in there really. The carbon dioxide is dissolved in the bottle, in the pop. But when we open this, you'll hear a little right? That's some carbon dioxide coming out. If I drank this whole thing all gone, you'd hear it coming out. It would be a burp. But we're going to open it. A little bit came out. And then we're going to quickly remove all the carbon dioxide. We're going to quickly remove it using Mentos mints. What happens, all the chemicals in the Mentos mint and the chemicals in there make the carbon dioxide stick to the Mentos and then move fast. So if I drop the Mentos, or in this guy, if I drop a pack of Mentos into a Diet Cola, we will see if we can remove the carbon dioxide quickly. Are we ready? 3, 2, 1. Whoa! Well, there's the carbon dioxide. We removed it quickly. What do you think? We have about half a bottle left. It's kind of flat because we took out the carbon dioxide. Yeah. Well, thanks for coming to Kitchen Chemistry. I'll see you guys next time. Bye.